Hello, Dave Morelli here. Welcome to this edition of Sniper Practice. Before we can start practicing precision marksmanship, we have to understand a little bit about external ballistics. And external ballistics refers to the time the bullet leaves the support of the barrel until it enters the target. And to understand this trajectory that we're trying to establish, we're going to have to go back to a little bit of physics. I know. If I'd have known physics was going to play this much of a part in my shooting, I'd have paid a lot more attention in school. Anyway, Newton's first law says every object in a state of uniform motion tends to remain in that state of motion unless an external force is applied to it. And as shooters, we also talk in velocity. And velocity to a shooter is feet per second. In other words, a unit of distance over a unit of time. In physics, velocity refers to the speed and direction of an object. And we'll explain more about how that affects the bullet here in a minute. Of these two forces that we're going to apply, in other words, if you were to shoot a bullet out of here at 2,700 feet a second, which is about what this thing would go, if no other force is applied to that bullet when it leaves the support of the barrel, it would travel on forever at 2,700 feet a second. We know that's not true in the real world because we have a couple of forces that are going to be applied to that bullet when it leaves the support of the barrel. The first one is going to be gravity. Gravity is a constant force that pulls things to earth. When that bullet leaves the barrel, it's going to be drawn to earth, and it's actually going to be accelerating to earth at 9.8 meters per second squared. The beauty of it is it's consistent. If you was to drop a bullet right here at my feet at the same time you sent one down the barrel, they would both hit the ground at the same time. One right here at my feet and the other one wherever out there. It's consistent force, which means it's going to do the same thing to that bullet every time. The other force that's going to be applied to it is friction as it travels through the atmosphere. Unfortunately, this friction is going to be different at different times when you shoot your rifle. It's going to be affected by temperature, it's going to be affected by humidity, barometric pressure, the altitude at the shot's taken, things of this sort. The changes in these atmospheric conditions are going to change the amount of force applied to that bullet as friction. And we'll learn how to account for that later. So the theory is if we keep the velocity the same, we keep that consistent, and gravity is consistent, then when we set up a point of aim, point of impact on a target, theoretically the bullet should take the same path every time and give us a good group on the target. So one of the most important things to do when you first set up your rifle is establish the average velocity of the load that you're using in that rifle. I like to take a 5-shot average to get my average muzzle velocity. What we'll do is take this rifle on the range and shoot 5 shots through the chronograph, and then we'll average out those velocities. This will give us our average velocity for those atmospheric conditions. Later on, if we have to make a shot in different atmospheric conditions, we'll be able to calculate those differences and adjust to account for those differences so the bullet will still strike the target at the point of aim. Okay, I just fired a shot through the chronograph. It came in at 2682, which is about right. This thing runs about 2750, but that's in 75 and 80 degree weather, and we're sitting, well, I haven't taken a measurement yet, but we're sitting a lot colder than that. We're probably in the 30s right now. So you can see that sometimes temperature makes a big difference. You remember when we talked about velocity also being a change of direction? When we shoot a bullet out at a target, when gravity is acting on it, it's pulling the bullet down towards Earth, and it's actually accelerating the bullet towards Earth. That, along with the slowing of the bullet due to the friction, is causing a change in direction of the bullet a little bit. And this is all part of the velocity factor. Okay, let's give her another shot. This is shot number 2. That one's 26.99. Which is turning out to be really good and consistent. It's a little over single digit numbers, but it's still pretty tight. Okay, when you're taking these shots, the whole idea here is to get your average velocity. But at the same time, we can be practicing marksmanship. I have a target out there, and I've got 2 shots on it now, and they're pretty much almost through the same hole. So that's the kind of accuracy that we're looking for. It's a 100-yard target. Take every shot like it's that 1,000-yard deer or elk or moose of a lifetime. Make your trigger squeeze exactly the same every time. Get a good, crisp trigger squeeze. That's something that you could be practicing while you're setting up your rifle. The trigger is one of the most important things for you to get good with as far as manipulating it to being an expert marksman. Let's give it another shot. That's right in there, and our velocity is 26.88. She's looking really good. One of the things that's important as a precision marksmanship is to get a chronograph. They're not expensive anymore. I got this one for Brownells for about 80 bucks, I think. It's plenty accurate. You put it on a tripod, set it about 5, 6, 8 feet from the muzzle. When you're getting your standard velocity, I have a little kit. I got a lot of things in there, and one of the things I have in that kit is a weather station like this one from Kestrel. This velocity is important, but it's also important to know what the atmospheric conditions were at the time I took this velocity. Different atmospheric conditions are going to cause different friction on the bullet, which is going to cause a change in the trajectory. Today, we're working at 43 degrees Fahrenheit, 38% humidity, and I don't need to do my altitude. I know the altitude here is 5,700 feet. And then the other important deal is barometric pressure, and today it's 30.27. We're gonna put all that in here. When we take a shot later at different atmospheric conditions, we can feed the different conditions into the computer, and it will, especially a ballistic program. I use Night Force's ballistic program. Sierra makes a great one. There's a bunch of them out there. When I put this information in here with the different atmospheric conditions, it will compensate for that when it gives me the adjustment that I want to make on my turret for a first round hit. The 550-yard shot at a relatively small steel plate. Listen for it. There it is, first round hit. There's another hit. Well, we got a good tight group out there, so we've done a few things today. We got our average velocity, which I'll figure out here in a minute. We practiced our trigger control, and we produced a respectable 5-shot group at 100 yards. I've averaged these out here. I had 2682, 2699, 2688, 2682. There's two that were the same. And 2672. I averaged it out, and my average velocity is 2685. That's what we'll use. The thing to notice here too, and to strive for, I know that this load is a really good load for this, other than the fact I've been using it for years. But the highest deviation is 27 feet a second. Yeah, I'd like that lower, but that's between the highest and lowest velocity. The other three are within a couple of feet a second, 5-6 feet a second. So this bullet at this atmosphere is leaving the muzzle very close to the same velocity every time. And if gravity is acting on it the same every time, the trajectory will be the same every time. And when you take a look at the group, it's obviously all coming together. It's well, I don't have a camera that'll get out there right now, but it's probably a half-minute group. So there you are. Get your velocity. That's the place to start with your rifle.